Question here. We're told that the gradient of the normal to the curve, and we can see there that it's a quadratic, but we have several things missing. And we're told that there's a point 24, at which point the gradient is negative a third. So we're calculating the values of a and b in the equation. So if we have two things we're trying to find, we know that we need to have two equations in order to find it. So the first thing that we can see is that if we know the gradient of the normal is negative 1/3, then that tells us that the gradient of the tangent, or of the original curve, is equal to -3, or +3, sorry. So the negative reciprocal. So if I differentiate, I can find that dy dx, if I had this originally, let's write this above, then I can see, there we go, that if I differentiate, I have 2ax plus b. So 2ax plus b. So that means that my function is equal to 3 at the point when x is equal to 2. So the gradient dy dx at x is equal to 2 is equal to 3. So we can substitute that in. So 2 times, or 2, we can just leave that as a times 2 plus b is equal to 3. So 4a plus b is equal to 3. And then the second equation, we know that when x is 2, y is equal to 4. That's given to us in the coordinate there. So that means that if I take the original function and I sub in that y is equal to 4, I know that x is always also equal to 2. So I can substitute that in. So 4 is equal to a times 2 squared plus b times 2 minus 10. And if I simplify that, then I can see 4 is equal to 4a plus 2b minus 10. And if I add 10 to both sides, 14 equals 4a plus 2b. So I have two different equations and two unknowns. I can solve those on my calculator using simultaneous equations, and I can find that the answer is a is equal to -2 and b is equal to 11. So that's using simultaneous equations, which is in apps, polysimult 2 and simultaneous equations, and I can change that to two equations and two unknowns.